Hey guys, welcome back. This would be slope-intercept form lesson 4.3. We're going to try and go through this one really quick. First thing here is we have some vocabulary. If you have your foldable with you might want to go ahead and write down some of these definitions. Slope-intercept form, an equation in the form of y equals mx plus b, where m is the slope, and that's the steepness of the line. It's the ratio of the change in rise over the change in run. And b is the y-intercept, and that's always going to be true anytime you put a 0 in place of x. The output will end up being the y-intercept. Take a little notice of this note here. When an equation is not in slope-intercept form, it might be easier to rewrite it before graphing. Next word here we have is a parameter. It's simply a placeholder in the equation or formula, and it stands in place for a future value that's going to come in. So in our equation, the m and the b are the parameters. They're waiting for some input values. The last one here is a constant function, a linear function in the form of y equals b. So there is no x value in there because the x would be 0, which means the slope is 0. A constant function where b does not equal 0 does not cross the x-axis. For our first example, we want to write a linear equation in slope-intercept form. Write an equation in this form that has a line with a slope of 4/7 and a y-intercept of 5. So the slope here, what we're saying is that m is equal to 4/7, and the y-intercept is going to be b equals 5. So all we got to do is substitute our 4/7 here and our 5 here, and our equation ends up equaling y equals 4/7 m plus 5. And remember, our slope here is a change in y over the change in x, starting at 5. For our next example, we have to rewrite the equation in slope-intercept form. Remember, it's sometimes easier to do that before you start graphing. So we're just basically going to isolate the y here. So the first thing we do is get rid of the x. So we're going to add 22 x's to both sides. This zeroes out. We end up with 8y equal to, and because the form is mx plus b, so the x comes first, I'm going to bump the 22x to the front, and the 4 is positive, so I add it to the end. Next step is to divide everything by 8. The 8's will cancel out on this side, leaving us with y equals. And then there are the remaining fractions. All we got to do is reduce them, find their GCF. So the first one has a GCF of 2, so we rewrite that as 11/4 x. And the second one has a GCF of 4, so we'll write that as 1/2. And this becomes our slope-intercept equivalent. Now they want us to write a linear equation from a word problem. Remember that slope here is a rate of change, so it's got to be a change in something, a rate. And then b, another way of thinking that is the intercept is a starting point. So the number of job openings in the United States during a recent year increase an average of 0.06 million per month. So this is people per month. Right there is a rate of change. So that's really representing our slope. And that occurred since May. In May, there were about 4.61 million job openings. So that's your starting amount. So that really represents, this part right here represents our y-int, or y-intercept. So our equation will be y equals, and then the slope was the rate of change up here, which is 0.06 x, since the starting amount of 4.61, so that's our y-intercept of plus 4.61. And we don't have to use the x and the y in the problem. We could have just as easy used m for months and j for jobs, and that would have worked just fine. Okay, so our next one, they want us to graph a linear equation that has a slope of -3/2 and a y-intercept of 4. So the first thing we want to do is write the equation. So y equals -3/2 is the slope, x plus intercept of 4. When we graph these, we don't really have to create a table of values when it's written this way because we have a point to start with, which is this point here. Remember that is really 0, 4. That's what the y-intercept stands for. So 0, 1, 2, 3, 4 is right here. Then we can use the slope, which is -3/2, to find other points in the graph. Now when you go to use the slope or apply the slope, that negative that's out in front, I highly recommend you make the negative go with the numerator like this, so that our first movement will be down 3 units, and our second movement will be to the right. So if we make the negative in the numerator, our second movement is almost always to the right. So we're going to go down 1, 2, 3, and to the right 1, 2, and there's another point. And if I want to draw a more straight line, I can go down another 1, 2, 3, to the right 2, there's another point. And I can also reverse that, go up 1, 2, 3, and to the left 2, and that's where I take the negative then and put it down on the 2. Get rid of my dots here, or my lines. Now I'll just come back and draw the best straight line that we can through the graph. And there's our line that represents every possible solution to the equation of 3x, or negative 3 halves x plus 4. We're going to do the same thing again here, graph the linear equation in slope-intercept form. The difference is this problem is not written in slope-intercept, so I want to rewrite it first. So the first thing I want to do is get rid of the 12, so I'm going to minus the 12x from both sides. That zeroes out, leaving me with negative 3y equals. I'm going to bump the 12x, the negative 12x up front, because that's what slope-intercept form looks like. And the last thing I'm going to do is get rid of the negative 3 by dividing everything by negative 3. This gives me a positive y equals positive 4x. And 18 divided by negative 3 will give me a negative 6. And this is my slope-intercept. So our first point is going to be the y-intercept of negative 6. And you'll notice the scale is going by 2's. So that would be 0, negative 6 right here. And our slope is 4 over 1. But here's the problem when we try to go 4 over 1. If I go up 4, which would be right about here, over 1 means I'm going up halfway through this mark. Because remember, I'm going by 2's here. So my suggestion would be to multiply everything by 2, because I'm going by 2. So times 2 would give us up 8 over 2. So from our point, up 8 would be 2, 4, 6, 8 would be right here. And then over 2, remember we're going by 2, so over 2 would be a point that occurs right here. So I can get rid of that line. And that can do it again. Up 8 would be 2, 4, 6, 8, and then over 2. Remember right there. And then do the best we can to draw our straight line through our graph. For our next example, they want us to graph a constant function. They want us to graph y equals 2. Now, if you wanted to, you could put a 0x plus 2 in there as a reminder that a constant function has a 0 slope, which means it's flat. So our constant function of y equals 2 is just going to go horizontally through the 2 on the y-axis.